Hi all, today we'll be discussing the LeetCode problem of the day, delete columns to make sorted 2. So here you're given an array of strings of all same length, and in this you can choose any set of indexes and you can delete those characters in all the strings. So suppose if you pick index 0, 2 and 3, so we need to delete the character in all of the strings. So once we delete, the new array of strings will become something like this: PEF, and then PLM, and then VYZ. So this will be your final array. So once you do the deletions, the strings in this array should appear in lexicographically sorted order. That means if you put all of the strings in the dictionary, so they should appear in the same order they are appearing in the array. So for that, you have to return the minimum possible value of indexes that you want to return, that you want to delete. Also, I just want to give a quick example of what the lexicographically sorted order means. So if we have two strings, in the first string we have C, D, F, G. Now in the second string, if the first character itself is smaller than the second character, then in the dictionary, this string will appear first. So these two, out of these two strings, this string is the smallest. But instead, if we have something like E at the starting, so no matter what we have in the rest, this string will always appear after this string. So what if we have the same characters, C, D, F, G? So in this case, these both character strings will appear together. So yeah, here we have equal to. So this is also a valid case. And suppose C is matching, D is matching, and at the first point, it is not matching. So at first point, if the character which is not matching is less than the above, that means this string will appear first. And suppose instead of A, if we have something like Z, then this string will appear after the above string. Now let's quickly look at the first example. So first we have CA, then BB, AC. So given the strings, if we arrange them in the dictionary, the order will be first we'll have AC, then we'll have BB, finally we'll have CA. So it is in the reverse order. So this is not the correct order. So we need to delete some indexes to make it in the correct order. So we can choose to delete this, the first index of all the strings. So when we delete them, the resulting string will become A, B, and C. So now when we arrange them in dictionary, this will be first, this will be second, this will be third. So they are in the lexicographically sorted order, and you needed to delete minimum one character, one index. The answer is 1. In the second input, we have X, C, Y, B, and then Z, A. So here, if we arrange them in dictionary, this appears first because X is the smallest among the starting ones. And then after that, we have Y. So Y appears second, then Z, A appears third. So these strings are already in lexicographically sorted order. So we don't have to delete any index. So the answer will remain 0. Note that you have to return the minimum possible value of answer.length. Like we saw in the first example, CA, BB, AC, we saw that if we delete this, then we get the answer. But for any string, we can always choose to delete all the indexes. That means I can delete this, I can delete this. Final array will be empty strings, and that is also valid. But since we want to minimize the answer, so we only choose to delete this first index. Now let's look at the final example. We have X, Y, ZYX, WVU, then TSR. So now if we put this in dictionary, T comes first, then this string comes first, then string, then this string. So we don't want this order. So what we do, we can delete the first index. Now after deleting the first index, again if we try to see, this comes first, this comes second, this comes third. So this also not lexicographically sorted. So again we try to delete this. Now if you see, this again comes first, this second, this third. So again it's not in lexicographically sorted order. So we also delete this. So once we delete all the three characters, the resulting array will be empty strings. So in empty string, all of them are lexicographically sorted. So the answer for this case will be 3. So the constraints, n is a string length, the array size length. So you can have at max 10 up to 100 strings, and each string length can be from 1 to 100. And it's guaranteed that in the string, it contains only lowercase English letters. Now let's go the approach. So the first thing that might come in our minds is we start iterating the strings from index by index. And suppose in the first index, if all the strings are not in, all the characters are not in lexicographically sorted order, then we delete this index. Now we move to the next index, and in this we see whether all these characters are in lexicographically sorted order. So here it is sorted, so we keep this row. So finally answer for this is 1 because we have deleted this row. So at first this logic might seems like it will work, but let's look at another example to see why this might fail. So these are the this is the example 1 2 3 4 5. We have 7 strings of size 5. So here first we try to compare index 0. So we can see A, then C, it's increasing, then D, then B, then it's decreasing. So B to A, then Z, then A. So that means this index 0 needs to be deleted because these are not in lexicographically sorted order. So far so good. We have deleted this index 0. Now let's move to the next index, which is 1. So here if we check this, we have C, then D, then E, then F, F, H, H. So this column, this index is lexicographically sorted. So we don't have to delete this column. Now let's move on to the next one. So here, if we see that we have a Z, then we have X. So after Z, it is decreasing. So by our logic, this column is of course not lexicographically sorted, but we don't have to delete this. Why? Because even though after Z, it is decreasing to X, but if you see the previous one, we have a C. So if we compare CZ and if we compare this DX, so we can see that the CX will obviously come before the DX in the dictionary. So even though after Z it is decreasing to X, we don't have to delete it. But we only know that we don't have to delete it because in the previous in the previous one we have C, and for the next string we have D. So C is less than D. So similarly, after X, it is again decreasing to C. So the next string will be EC. But again, we don't need to delete this because we can see that the previous character, which is E, is greater than D. So we don't need to delete it. And then after C, you have F, F, and H, H. So once you process all these characters, you can see that we don't have to delete this column. Even though it's not lexicographically sorted, we don't have to delete it. So now let's look at the logic, how we can solve this. So yeah, initially we have 7 strings. In that, we'll try to fix the first string. So the first string is fixed, so I'll mark this as true. And all the rest of the strings are false. So they are not fixed. false and false. So once we do it, first I'll iterate on this entire column and check whether if this is lexicographically sorted or not. So first I see A, then C, then D, then B, then A, then Z, then A. So we can see that this is not lexicographically sorted. So we want to delete this column. Also note one thing, that when we check if this all the characters are in lexicographically sorted order, we check it with the previous character. So when you are at C, you'll check whether C is greater than or equal to the previous character. And then for D, you'll check if D is greater than or equal to the previous one. Here it fails because B is not greater than or equal to the previous character. So B is smaller than D. So one thing we need to notice, we only need to check when the fixed is false. So here fixed is false, that's why we check for all these values. So after checking all the values, you see that this column should be deleted. So in your answer, you will count 1, and which indicates this column should be deleted entirely. Next, you'll move on to the next character. So in the next character, you'll always start iterating from the first string, I mean the second string, because the first string is always fixed. So when you start iterating from here, first you'll see D. So it's not fixed, so that's why you'll check for this. So D is greater than the previous character, so it's safe. Then you'll check E is greater than the previous one. Then F is greater than or equal to the previous one. Then again you have F here, so F is greater than or equal to the previous one, so it can also be equal. Even if it's equal, it will be lexicographically sorted. So then again you have H is greater than or equal to the previous one. And then the final H, this is also greater than or equal to the previous one. So once you have traversed on this column, you see that this column doesn't need to be deleted. So you will start to fix the elements. So once you know that this column should not be deleted, you will iterate on this column again, and you'll do something like this. So if the current character is greater than the previous character, so this string is fixed. You don't have to delete this string. So I'll explain you why. So in the previous example, this is deleted. So for clarity, I'll just put a strike on this. Yeah. So now you're at this D, and you know that this column will not be deleted. So this D is greater than the previous one. So I will mark this as true. So that means this entire string is fixed. Next, you're at E. So E is again greater than the previous one. So this string is also fixed. I'll mark it as true. Next, you have F. F is again greater than E. So for this as well, I'll mark it as true. Now here, F is not greater than the previous one. It is equal to the previous one. So it still remains false. Then you have H. So H is greater than the previous one. So you will fix this one. This is true. And finally, you have this H, and H is not greater than the previous one. So this remains false. So now we might have a doubt that what this true to true false denotes. It denotes that if we look at this string, it is true. That means this string is fixed. So far we have the strings like this: C, D, E, F, F, H, H. Now in the upcoming columns, yeah, after C we have Z, right? Z. So in the upcoming column here, no matter what character we have, this string will always appear first. So here we can see that after Z we have an X. Even though X is less than Z, it doesn't matter, because in the previous one, D is always greater than C. So in the dictionary, even though we can have any character which is smaller than the previous character, this string will always appear in the same position. So that's why we mark it as true. So what I mean to say is, after traversing on this string or on this index, we have this as the states: true, 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 false, true, true. So that means, uh, since this is true, no matter what characters we have here, the answer doesn't matter. And same thing for this true as well. Here, no matter what characters we have, it won't change the answer. So now let's move to the next next iteration. So next index. Now we are at index 2. So we start from here, right? So this is true. That means we don't need to check what character we have here. So we simply skip it. Next we are on here, but again we see this string is true. That means this string is fixed. So you don't need to check what character it's present here. Then you are at this f. So again for f it is true. So you don't need to check. Now for this f, you see that it is not fixed. So you need to check whether it's violating or not. So this current character is greater than or equal to the previous character, so it is not violating. Then the next character h, it is true, so you skip it. Then again for the h, it's false, so you will check, but since it is greater than or equal to the previous one, it's fine. So once you iterate on all the strings, you are sure that you don't have to delete this string. You don't have to delete this index. So once you are sure of that, you'll again iterate on this and check whether if I have any place where the current character is greater than the previous character. So I will try to make the status from true to false. So you will iterate on all the false states. So here you have false. So I have an f. So f is not greater than the previous one. So this remains false only. And again here we have an f. So h is not greater than the previous one. So this remains false. So this index is now done. Now let's move to the next index. So here it will be a bit more clear because here the state will be changing. So again, this is true, so you will skip it. This is true, you will skip this. True, skip this. True, skip this. So all these characters, it doesn't matter what you have here, the answer will not change. Now here you have false, so you will check and h is greater than equal to the previous one, so it's fine. Next it's true, so you skip this a. Here if it's false, so you check the b, so b is greater than equal to the previous one, so it's fine. So once you check all these strings, you are sure that this column will not be deleted. So when you're sure that that column will not be deleted, you'll check for all the false. That means you'll check for all the strings that are not fixed. So first you'll check for h. So h is not greater than the previous one, so you don't do anything. Here, if you see for b, so b is strictly greater than the previous one. So since b is greater than the previous one, you can fix this string as well. So from false, this will change to true. Now let's move on to the last one. So again, true, you don't check this. This also true. This is also true, you don't check. X is also true. Y is false, so you check it. So for this y, we see y is greater than or equal to the previous one, so it's fine. Then for the next one, x, even though x is less than y, since it is true, it doesn't matter. And here as well, even though b is less than x, but b is fixed, so it doesn't matter. Now after completing the iteration, you are sure that this column will also not get deleted. So you'll iterate again on the false values. So you are at y. So y is strictly greater than the previous one. So you can also fix this string as well. So this string will be true. And then the iteration stops. So once the iteration is done, this is the fixed Boolean value. and at the end you will just return the answer. And at any point in between, if you see that all the values in this are true, there itself you can directly break and return. This is why, because suppose we have strings like this, A, B, C, D, E, and then the rest of the string. So here after iterating the first column, you'll get the fixed values as all true, because the current character is strictly greater than the previous one, so all are fixed. Once this is done, no matter what you have in the remaining places, it is already lexicographically sorted. So that's why at any point, if you have the true values, all the values as true, then you can directly stop the computation and return whatever the answer is so far. Now let's quickly code the approach. So first let me take the size of the array, and then a Boolean array fixed, and I'll also take a fixed count to know so far how many strings are fixed. Fixed count is 0, and also the answer. So answer we can have delete. Initially we delete nothing. Now let's start iterating on the column wise. So first column will be 0, column will be less than strings of 0 dot length, and column plus plus. So like we discussed, the first string will always be fixed. So I can have fixed of 0 will be true, and since the 0 is fixed, the fixed count will be 1. Okay, so first let me take a Boolean variable which will indicate whether the current row is deleted or not. Sorry, the current column. Initially it will be set to false. Now let's iterate on all the strings. We'll start iterating from the first string, less than n plus. So like we discussed, if it is fixed, then we continue. So if fixed of I is true, that means we don't need to check for this. So now after this, it means fix of I is false. So when it's false, we'll check whether it is in lexicograph. If it is not in lexicographically sorted order. So for that, strings of I dot column dot column. If the current character is less than strings of I minus 1 dot column. So if the current character, if the character of the current string is less than the previous one, that means it is violating the sorted property. So here we can directly say that column deleted is false. So we need to delete this column. And since we delete the column, we will increase the delete count by 1, and we can just break out of the loop. So once it is done, if the current column is not deleted, so that means not of column deleted, then we'll just iterate on the strings again to change the status from false to true. So we can say if my current string is not fixed, and strings of I, the current character should be strictly greater than the previous character. If it is strictly greater, then only I can fix the current character. So fixed of I is true, and also we can have the fixed count increase. And then this is just to optimize our code. At any point, if fixed count is equal to n, we can simply break, and at the end return answer, sorry, return delete. So let's quickly do a dry run for this example. So initially we have true and all false. So when we start iterating on this, so if the current character is less than the previous character, we break. So the current character is not less than the previous one, so we don't break. And for this z, again, it is not violating. This z is also not violating. So once this for loop is done, we see that his column is still false. So not of his column is true. So we enter this if condition. That means we are not deleting this column. So again, we iterate on this and check uh, if it is not fixed and the current character is strictly greater than the previous character. So for this v, the current character is not strictly greater than the previous character. It is equal to the previous one. But for this z, we can see z is strictly greater than the previous one. So due to that, we can go ahead and fix this string. And for this z, it is again equal, so you don't change anything here. Now after this, you move to the next column. In the next column, you have first one is D. Then here you have E. So E is greater than D, so it's not violating. Then again V is greater than E, it's not violating. But here if you see L is less than V, so it is violating. So we have to delete this column. So this column is marked as deleted, and deleted count is 1. So this column is deleted. Now for the last column, we are at Y. We are at I. So I is, so here only it breaks. So I is less than the previous character. So this column should also be deleted. So the current character is less than the previous character. So we mark the column deleted as true, and then we break. And we increase the delete, so delete will now become 2. And after that, since the column is deleted, we don't enter the if condition. And yeah, now the processing is done. So at the end, the value of delete is true. Delete is 2, so we return 2. We tested now. Submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, here we are iterating on the column length, which will be equal to the string length. And inside that, we are iterating on the number of strings. It's order of n. And here also, we are iterating on the number of strings. So total complexity will be order of n into length of the string. Coming to the space complexity, it's again constant, because we are just sorry, it's not constant, it is order of n because we are declaring a boolean array of size n. So space will be order of n. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.